welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem number 56, merge intervals. Given an array of intervals where intervals of I equals start of I, end of I, merge all overlapping intervals and return an array of non-overlapping intervals that cover all the intervals in the input. So if we were given this input here of intervals 1, 3, 2, 6, 8, 10, 15, 18, how might we merge these? Well, we can see here that there's an overlap between these two intervals, right? Because the 2 is within this interval. So we can merge these two and we can get 1 and 6. Then what we can see is that in this interval there's no overlap because the end of this one does not coincide with the start of this one. So these two are disjoint. This one, there's also no overlap between these two because obviously the start of 15 is after 10, so there's no overlap here, so it'd simply be 8 and 10. And that's essentially what we want to do, is we want to take our intervals and we want to look whether the interval that that we're considering, if its start is less than the end of the last interval, then what we want to do is we want to merge those two, and then we want to basically, do that for all the intervals, but then we also have to consider, say we merge these two into 1 and 6, we now have to consider, for the next one, 8 and 10, when we're doing it, we don't want to be going off of, 2 and 6, we want to be going off of the merged interval of 1 and 6. And that's the approach that we want to take. But there is actually one thing to notice here, which, may not always be true. So if you look here, these intervals are actually sorted based on the start of, the interval, which is not actually guaranteed to us by this problem. So for example, if this interval was given to us as, 1, 3, 8, 10, and then 2, 6, that would mess us up, right? Because we would try to, we would first try to merge, 8 into 10. Obviously, there's no overlap. So we would say, oh, okay, well, there's no overlap. Therefore, we need to keep them the same. And then we would get to, 2 and 6. Oh, there's no overlap again. We can just add it in. No. You would have to actually merge it back in time with this one. And the reason that this isn't good is because we actually have to, if there was a lot of these intervals that we'd had to merge it into, then we'd have to be trying like multiple places, which isn't ideal and is going to make our algorithm a lot slower than it is. So to combat this, what we're going to do is before we do this merging that we went over in the first step, we want to actually sort this to make sure that it's sorted based off of that first element. Once it's sorted like that, then we can do the processing that we did in the initial illustration, where we took the intervals and we simply merged, based on the end of one interval and the start of the other interval. So that's what we need to do. We have to accept this sort in the beginning. Otherwise, despite the fact that we're doing an n log n sort here, it's still going to be faster than if we tried to just leave it unsorted and then merge, intervals every which way. So that's the approach that we want to take, and the code is actually really simple to write. If this part didn't make sense, then when we go into the code editor in a second, you'll see what we're going to do, and it's going to make complete sense to you because it's really, really simple. So let's go over to the code editor and write the code for this problem. So we're now back in the editor, and it's time to write the code. The first thing that we want to realize is a little bit of an edge case. If there's only one interval provided to us in intervals, then there's nothing for us to merge. So we can simply just return intervals because there's nothing for us to do. So we're going to say if the length of intervals is less than or equal to 1, we can simply return intervals. Now remember what we need to do is we need to sort intervals based on the start of each interval. So that way it's in the nice order that we can work with, and we can do the merging without having to worry that things are not in the correct order. So we need to sort our intervals. So we're simply going to say intervals.sort, and the sort function will actually just do that for us based on the first element in these lists. It's quite convenient that it works out that way. So now what we need to do is we need to define our result. So we're going to say res is going to be equal to a list which contains intervals of 0. remember that we're always looking back at an interval and looking to see whether its start comes before the end of the previous interval. Obviously, for the first interval, there's nothing before it, so we simply put the first interval into our result, and then any subsequent intervals that we're working with, we're going to check whether or not they merge into whatever is already in result, because the result's going to be storing the kind of the merged state of our intervals. So now we just need to iterate over all the rest of the intervals. So we're going to say for start end in intervals starting from 1, because we just handled the very first index, right? This interval 0. What we're going to do is remember, if the current start is less than or equal to the previous interval, and remember that we're putting all merged intervals into res, so we're actually going to be looking into res. So we're going to say if it's less than or equal to the previous interval's endpoint, then we know that we need to merge them, right? So we're going to say res minus 1, 1, which is the endpoint of the last interval that we have in our result, is now going to be equal to whatever the maximum of the end, the current end for our interval that we're working with, and whatever its current end is. Oops. We're going to do that. Okay. Otherwise, if there's no overlap, we know that our current interval has no overlap with the previous one, and we can simply just add it to our result. So we're going to say res dot append, and oops, I'm going to append start and end here. And that's all we have to do. We go through all of the intervals, and we're simply going to just, do the merging if we can. So basically, if the current interval start is less than or equal to the previous interval's end, and if it is, we're simply going to just set the endpoint of the previous interval to be the, whatever the maximum of end here is, or, the previous end. And the reason that we don't change the start point is, remember that the intervals are sorted by start. So there's no way that this start point could be before the other start point, because obviously, it's sorted by start. So anything that comes after a particular interval will always have a start after it, because they're sorted on the start one. So we don't have to worry about changing the start. We just have to worry about the ends, because that part may need to be checked. Okay, so that's going to be the problem. Let's submit this, make sure that it works, and we can see that it does. So what is the runtime complexity of our algorithm? Well, here we have to do a sort. So sorts are always going to be big O of n log n. And then we have to basically go over the entirety of the array and, potentially merge all the intervals. So going through that, the intervals is going to be a big O of n operation. But because the n log n is actually larger, asymptotically, what's going to happen is that our algorithm is just going to run in big O of n log n. This n log n will basically trump the O of n here. So we can basically disregard it in the asymptotic runtime complexity. So for space complexity, we do have this res, which in the case that intervals, all the intervals here are disjoint, so there's no overlap at all, then res will end up storing basically the exact same thing as intervals, which means that our space complexity will just be, a list here. Intervals, which is just big O of n. So it depends on how large intervals is going to be. So that's how you solve this problem. It's quite a simple one. The code is really easy to follow. And yeah, if you enjoyed this video, please leave a like, comment, subscribe. If there's any other videos you'd like me to make, please leave them in the comment section below. I'd be happy to make those for you guys. Just let me know which ones you want to see, and I'll get back to you. Otherwise, in the meantime, happy coding. Bye.